watching this video, you're watching the first lesson in the unit of probability. This unit will be talking about what probability is and how we can calculate it. So I'd like to start with this unit with the question of what is probability? When I ask the question, what is probability, or when I say the word probability, the first thought that probably comes to your head is gambling or betting or risk. And to some level, it is that. However, the proper definition for probability is the measure of how likely an event will happen, right? Probability is the measure of how likely an event will happen. So here we have a roulette wheel, classic example of gambling and casinos. You think of casinos, that's the first thing you think of. And the way it works is you have a little marble and the wheel spins and the ball's got to land in one of these slots. Now, probability works in because people need to bet on where the marble will land. Now, they can either say, oh, it's going to land in red or black, and that basically gives them a 50% chance. Or they can pick a number, which reduces the likeliness of the ball landing on their spot, but a greater payoff. So probability is the study of how this mechanism works, right? So let's say you bet on 35. Okay. Oh, bad color. Well, the probability, I think that's the highest one, 35, 36, okay. So there's 36 spots. So you have to get one spot out of 36 in total. Well, that means you have a very unlikely chance of actually winning, right? So probability is the study of how likely is it for this event to occur, for the marble to land right on the spot you picked. So probability is the measure of how likely an event will happen. So probability is usually given as a fraction, a decimal, or a percent, right? And if you remember from our last year and our review from grade 7, you can convert a fraction into a decimal and into a percent, right? 1/2 can be converted into 0.5, and 0.5 can be converted into 50%, and in any which way you want. So probability is usually given as one of these three. Now typically it's percentages, and sometimes it's fractions. Not so often you'll see decimals and whole numbers, but you can see these numbers show up on a test or on a question. So we'll start with a practice problem, right? We have a wheel, just like our roulette wheel with fewer sides. So the question I'm asking is, what is the chance, or what are the chances, the probability of landing on yellow? How hard would it be for this guy right here to land on yellow? Well, first step is we need to find out. We need to find out how many possible outcomes there are. How many possible outcomes there are. Then we also need to find out how many outcomes we want, right? How many outcomes are we looking for? So in this question, it's asking for yellow, and we need to know what are the total number of outcomes. Well, it could land on blue, it could land on green, this weird brownish color, yellow, red, or orange. It could land on any of those. So in total, there are 6 outcomes, including the one we want. Okay, now how many outcomes do we want? Well, the question is asking us the probability of landing on yellow. So what we want to find out is the probability of yellow. So we're looking for how many outcomes? Well, just one here, just yellow, right? We're looking for the probability of just landing on yellow, right? There are 6 outcomes in total. We only want one, so we can calculate probability with this equation, and this whole unit will be revolving around this one calculation. You take the number of outcomes we want, that we are looking for, that the question is asking, and you divide it by the total number of outcomes. Well, we know we're only looking for one outcome, right? So outcomes we want, well, that's 1, right? Total number of outcomes divided by, right? As you know, this can be divided by, well, there are 6 outcomes in total. So 1 over 6. And this would be our probability. That is how we find the probability of landing on a yellow, on this wheel. To get this, we have a 1 in 6 chance. To get this, we have a 1 in 6 chance of landing on yellow. Well, what does that mean? Well, again, remember, you can give the answer as a fraction, as a decimal, or as a percent, and I will ask you to convert in between, so you should know how to do this, right? So 6 outcomes in total, 1 outcome we want, so the probability is 1 over 6, whereas a decimal, 0.16667 forever, it repeats, or as a percent, 16.7 if I round up. So I only have a 16.7% chance. Now if I looked at this and I said, you have a 1 in 6 chance of winning, that actually sounds kind of good. But if I said you have a 16% or just under a 20% chance of winning, then that doesn't sound as nice. That sounds less likely than 1 in 6. And that's actually how people will use probability to trick you. They'll say, oh, it's only 1 in 6. So if you spin it 6 times, 1, 2, 3, oh, 3. Oh, lucky me. But you may not always get it. And what it really means is you have a 16.7% chance of actually getting that yellow. It's not a very high probability, right? Even though it's only 6 spots, you only have a 16% chance. So if we were to go back to our roulette wheel with, let's say, I think 36, that's the highest number I see, 36, well then you have a probability of 1 over 36, right? If 1 in 6 is a 15 or 16% chance, what's 1 over 36? Well, 1 divided by 36, 0.27, right? That's the decimal. What does that mean? Well, if we convert that into a percent, that's like saying you have a 2.7% chance of winning. You have a 2.7% chance of winning. So you'd probably have to spin this about 20 times before you get the number you want. And you'd have to keep betting the same number. So you have a 2% chance, or a 1 in 36%, 1 in 36 chance to get a number on a roulette wheel, and that's how casinos make money, right? You have a very low chance of actually winning. So another way to show a probability question, another way to ask a probability question, is to use P and outcome. So what this means is P stands for probability, bracket, the outcome you're looking for, and then ask that question. So in our first example, the question was, what is the chance or probability of landing on yellow, just like in our wheel here, right? What is that probability? Well, instead of writing this long sentence, we could just say P of Y, right? P of yellow, right? What is P of yellow? It's so much shorter than that big long sentence. So you may see this a little bit this year, as well as in the years to come, you will see this more and more, right? Instead of writing this long sentence, you would just say P of Y. P, the outcome you're looking for. Instead of saying, what is the outcome, or what is the probability of getting yellow on the spinner, you would just say, what is P of Y? Another thing you will see a lot of are word problems, because word problems are fun. You will see a lot of them because it forces you to take information and use it in a way in which you get the correct answer. And there will sometimes be useless information and sometimes be a lot of information that you have to add together. An example of that would be this question. A box is filled with candies in different colors. We have 40 white candies, 24 green candies, 12 red candies, 24 yellow candies, and 20 blue ones. If we've selected one candy from the box and we did not peek into the box, what is the probability of getting green or red? Well, let's look back at our equation first. This is the equation we need to use. Outcomes we want over total number of outcomes. So if I move this question down, we'll do that later. We're looking outcomes we want. Well, the question is asking for green or red. So these are the outcomes we want. So we're looking for the probability of getting a green or a red candy. Well, we have 24 green ones, right? And we have 12 red ones. So the total outcomes we want is 24 for the green, right? Plus 12 red, which gives us 36, right? So we have 36 potential outcomes. 36 potential outcomes that would give us a result that we are looking for. Okay, well, again, our equation is outcomes we want over the total number of outcomes. So what's the total number of outcomes? Well, it's 40 and the green and the red and the yellow and the blue. So 40 plus 20 plus 24 plus 12 plus 24 again. So let's pull out our calculator so we can do this quickly. So we have 40 plus 24, right? Plus 12 plus 24 plus 20. We have 120 candies. All right, so we know that the total number of outcomes is 120. And again, 120. So we know that it's what we want, outcomes we want, right? Over the total. Sorry about this annoying clicking. Total. Well, what we want is 36. That's the total number of outcomes we want, 36. Over 120. Right? And again, we can use our calculator because I just want to be fast. We have 36 divided by 120, which gives us 0.3. Right? Which gives us 0.3. Which is the same as saying 30%. Right? So I can give you now, of course, I would have to simplify this fraction if the question was saying, oh, what is the fraction? Always simplify it, right? Simplify this fraction, but in essence, you have the fraction, you have the decimal, and you have your percent. And so you have all three. And on questions, I may ask you, give me all three. So know how to convert them. And make sure you simplify this. I'm just going a bit fast. All right, so let's clean this guy up. We have numbered cards from 1 to 20. And we pick one at random. So we have cards 1 to 20. And we have the question asking us, find the probability that the card you pick is a multiple of 2 or 5. Okay. Well, we would need to find out how many multiples of 2 are there in between 1 and 20. Well, we have 2, 4, 6, 8, 10, right? That's already 5. And you already know that every other number is a multiple of 2. Every other number is even, right? If you know your divisibility rules, you know every other number is even, so that must mean that 10 numbers, right? Half the numbers are multiples of 2. And we're also looking for a multiple of 5. So the number of cards that are a multiple of 2 or a multiple of 5. Well, we know 5, 10, 15, 20. You know that there are 4 5s in 20, so that's also another, 4. There are 4 multiples of 5 in between 1 and 20. So the total number of outcomes we want is 14, right? 14 total outcomes we want. Well, what is the total number of outcomes? Well, the question gives it to us, right? The total number of outcomes, well, there are 20 cards in the deck, 1 to 20. So it'd be 14 over 20. And again, simplified, you can make that 7 over 10, right? And that would be the same as saying 0.7. And that would be, sorry, my mouse is being very strange, 70%. Right? So that's how you'd solve a basic probability question. You find out, what is the question asking you? Well, it's asking me in this one multiples of 2 or 5. And it's asking me to pick cards from 1 to 20. So it seems easy to find out the outcome of one event, the spinner, but what happens if we have 2 events? What happens if we have, now I don't have a coin, but I have a spinner that does heads or tails, so let's say it's a coin, and we have a spinner. So we have a coin, for example, and a spinner. What is the probability of getting specific outcomes on 2 events? Well, first we need to see if the events have an effect on each other. Does one spinner affect this outcome or the other outcome? So if I spin this one, does that make one outcome more or less likely? No, right? This guy does not affect this guy. If I get tails, it doesn't make red more likely or orange more likely or green more likely, right? Heads or tails on this side does not affect this side. Perfect. So if we are measuring the outcomes of events that do not affect each other, they don't affect each other in any way, then we say that these events are independent events. They are independent. They do not affect each other, they don't touch each other, they don't change each other's outcomes. You need to know this because on a question I'll ask you, is this event independent or the other kind dependent? So you need to know what independent events are. Independent events are events, or like for example a spinner, where the different events don't affect each other. They don't change the probability of the other event. So what is the probability of getting heads or getting heads with green or orange? So we want heads, right? Perfect. With green or orange. Right? Perfect. We got the outcome we want. What is the probability of getting that? How do we find that out? We have 2 different events. Well, we need to find out the total number of results we can get. And this is another key term you need to know, sample space. Your sample space is the total number of outcomes. Well, we know the total number of outcomes is 3, right? 1, 2, 3. And we know the total number of outcomes for this one is 2, right? 1, 2. Do we add them? Are there only 5 outcomes? Please don't say yes, because that's not true. Well, to find the sample space, we can draw something called a tree diagram, right? We look at one event on its own. We find the total number of outcomes for their event. So in this case, we're using the spinner for the heads or tails, right? There are only 2 outcomes. Heads, and we'll denote that with an H, or tails, we'll denote that with a T. There's only 2 outcomes. Okay, and now we know that we have another spinner with 3 outcomes. We have orange, right? We'll say O. We'll say green, G, and red, R, right? Right? First event, I don't know why it says third event. I'll fix that right now. Second event, because it's 2 events. Second event, right? So it's the outcome, total number of outcomes on the first event, and the total number of outcomes on the second event, right? And we can draw a tree diagram, right? Now before, if you added it, you would just say 5, but we know that the total is 6 from this one, right? So heads or tails? Well, you could spin this, hopefully it lands on heads. Yeah, you get heads. And if you spin this, you could get heads with green, you could get heads with red, and you could get heads with orange. And the same goes for, hopefully it lands on tails, the same goes for tails. You could get tails with red, you could get tails with green, and you could get tails with orange. So each of these are an independent event. You could get heads with red, heads with green, heads with orange, or you could also get tails with red, tails with green, and tails with orange. And the total number of outcomes you have on the end of this tree diagram, because it kind of looks like a tree, gives you the total number of outcomes, or what's called your sample space. Your sample space. Right? Heads or tails are the first one. And I like to start with the simplest event, because then you start small and you start branching out rather than having a large number of branches and thinning it out. So you can have heads with reds, heads with green, heads with orange, tails with red, tails with green, and tails with orange. And that's a total number of 6 outcomes. So we know our total, right? And in our calculation for probability, if you go all the way back up, the total number of outcomes, also known as your sample space, is your bottom part. So we already have half our calculation. Awesome. Then we're looking for the outcomes we want. Well, in the first question, it's asking, go all the way back, what is the probability of getting heads and green or orange, right? Heads with green or orange. Well, if we look at our tree, 1, 2, 3, 4, 5, 6 in total, 6 events in total, only 2 of them are heads with green and orange. Outcomes at work are 2. So using a tree diagram and then writing this out gives you A, the total number of outcomes, also called your sample space, and B, the total outcomes you're looking for, right? It gives you the equation you're looking. Yes, the tree diagram can be a little bit hard sometimes. It can be long to write it out, but it gives you all the information you need. So outcomes we want, total number of outcomes. Okay, outcomes we want is 2 because we found heads with green, heads with orange, and total number of outcomes is 6. So 2 over 6, which you would simplify, and you would get 1/3, which is the same as saying 0.33, or 33%. That's it. That's how you calculate percent. Now, here we have another problem. We have a 4-sided die, and I shouldn't say dice, die, and a 5-colored spinner. What is the probability of getting an odd number with green and blue? What is the probability of getting an odd number with green and blue? So we'll solve that one together in class, and we'll take a look at how to calculate it. But let's take a look at how to solve this in the video. So we take our spinner, I gotta move some stuff around. Oh, he doesn't want to move. All right. So I'll make some room. The probability of getting, and I like to highlight what I'm looking for, an odd number, green and blue. So we have a 4-sided die. Well, an odd number would be 1 and 3, right? Getting 1 and 3. So we have 2 outcomes that we want. So it's going to be hard to fill this out. Let's add a new slide. Okay. So we have a die, right? We have an odd number. We're looking for an odd number with green and blue. Okay. So the number of outcomes for the die is 1, 2, 3, and 4, right? These are all the outcomes the 4-sided die can give us. And each one can be paired off with a color from the spinner. We could get 1 with red, orange, green, blue, yellow. We could get 2 with red, orange, green, blue, yellow, and so on and so forth, right? So 1, 2, 3, 4. Now you can already see that this can be a bit tricky, but as you move forward, and if I space this out, let's see if I can space this out a bit more. Okay, and I'll take my eraser and fix this up a little bit more. 1, 2, 3, 4, 5, right? I have 5 branches off this. This could be a 1 with a green, a 1 with a blue, a 1 with a yellow, a 1 with a red, and a 1 with an orange. So we have 5 outcomes, and we could have 1, 2, 3, 4, 5 coming off. I'm going to do this really roughly because it's a lot harder to do it on this. 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5. Now, I drew this very roughly. In class, I'll show you how to draw it more neatly. It should look more like this. I'm just trying to go through it more quickly so that you don't have to hear the incessant clicking. So we have 5 here, 5 here, 5 here, and 5 here, right? 5 outcomes for each number. Well, if you have 5 outcomes for each number, and you have 4 numbers, 5 times 4 is 20. You have a total of 20. Well, how many outcomes? So we have our total. How many outcomes are odd with green and blue? Well, first off, we want to pick our odd numbers, so I'll pick green for the ones we're looking for. So we're looking at this guy and this guy. And green and blue are 2 colors, right? So we'll take 2 and 2, which would make it 4. So in total, we have 4 outcomes we're looking for. So our calculation will become 4 over 20, which is the same as 2. All right, we can keep going. 2 over 10 and 1 over 5th. Sorry, I just divided by 2 for some reason. You could just divide it by 4. But you'd end up with 1/5 anyways. Okay, we have 1 over 5 as our fraction. Our decimal would be 0.2. That's a terrible 2, but yeah. And our percent, you know how to convert, hopefully you remember, 20%. And so that's how you'd solve it. So in your textbook, page 416, questions 2, 3, and 4. That's it. That's all I really want you to do. It really just focuses on how to draw tree diagrams and how to carefully calculate the probability of independent events. You need to know what an independent event is. If I were to find that. Next, you need to find what an independent event is. You need to know what sample space is. You know what sample space is. You need to know how to draw a tree diagram. Now, again, the example I gave in this video was short and a little messy just because it's hard to draw on the Mac, but I'll show you in class how to draw it. And it should look something like this. This is a very simple one. And it should tell you the total number of outcomes. And then you could find the outcomes you are looking for. And again, the calculation for calculating the total number of outcomes that you are looking for, or the outcomes you're looking for, the probability of an event you're looking for, is outcomes you're looking for over the total number of outcomes. This was a relatively long video for an introduction on probability, but it is a foundational one for your understanding of how it works. If you have any questions, please come find me in class. I'll see you next lesson.